Look at this wet trail. It's 2016, inside a high-security aquarium in New Zealand. An octopus named Inky has vanished from a locked, reinforced glass vault. No broken glass, no tripped alarms, just a trail of water across a dry floor, leading straight into a 164-foot drainpipe. And then, out to the crushing black of the ocean. How does an animal the size of a rugby ball pull off a jailbreak from a sealed aquatic prison? Modern aquariums are fortresses. They are engineered to safely contain the ocean's most ruthless apex predators. But octopuses treat these concrete and glass vaults like playgrounds. In Germany, an octopus named Otto got bored and systematically short-circuited an entire building's power grid. He just sniped an overhead spotlight with a precise jet of water. In Wellington, researchers set up security cameras to catch a human thief stealing their lobsters. Instead, the grainy footage showed an octopus creeping out of its tank, executing the crustacean next door, and casually commuting back home before dawn. These aren't accidents. They are calculated biological heists. But here's the mystery. The physical security at these facilities is airtight. So how are they actually getting out? To be fair, the obvious answer is usually us. Humans make mistakes. A keeper leaves a lid cracked during feeding time, and the opportunist slips out. But that didn't explain the locked tanks. So, researchers assumed it was brute force, mechanical strength. They thought these animals were just muscular enough to bench press heavy lids. Aquarists went to war. They started tying down covers, installing heavy-duty clamps, securing the perimeters with dense industrial nets. But there was a massive problem. The octopuses were still vanishing. Even with heavy locks and clamped nets, the animals systematically threaded their arms through the tiniest invisible seams in the armor. Pure brute force didn't explain how they were finding these microscopic structural weaknesses. Then, biologists looked closer and found something completely alien. Biologists realized they had to completely rethink the machine. They set up specialized cameras and complex puzzle boxes. They started mapping the creature's neurology, and what they found was a biological network that shouldn't exist. An octopus has about 500 million neurons, roughly comparable to a dog. But the architecture is totally decentralized, a ghost in the machine. Only a third of those neurons are in its central brain. The other 2/3 are distributed across its 8 arms. Each arm has an independent axial nerve cord, which means an octopus's arm doesn't just take orders. It thinks, it plots, it moves on its own. And it gets weirder. Specialized chemotactile receptors on their suckers allow them to literally taste the acrylic, the metal, the glass, just by touching it. They aren't just feeling for a way out. They are tasting the structural integrity of their prison. But a hyper-intelligent arm still has to pull a massive body through solid matter. And the real answer to how they do that? It defies the laws of physics. The ultimate secret to the great octopus escape is its hydrostatic skeleton. They have absolutely no rigid bones. Their bodies operate through the transmission of elastic energy in fluid-filled tissues. When an octopus finds a crack, it doesn't push through it. It dynamically liquefies its shape. It shifts its internal organs in real time to maintain volume while squeezing through impossibly tight, razor-sharp gaps. There is exactly one physical bottleneck in this entire biological wood chipper: the beak. A hard, parrot-like mouthpart used to crush crab shells. That's it. If that tiny piece of chitin can pass, the rest of the massive animal flows right behind it. A 100-pound giant Pacific octopus can morph its entire mass through a hole the size of a lemon. Smaller ones can flow through a gap the size of a coin. When you combine an alien intelligence that rapidly maps weaknesses with a body that can melt through solid defenses, no standard lock on Earth can hold them. This bizarre ability didn't evolve for our amusement. It is a radical, uncompromising survival strategy. Lacking a protective shell, the octopus had to develop massive ecological intelligence to outsmart predators and blend into the violent, unforgiving ocean. They are den seekers by nature, cramming themselves into tight crevices to survive. So, when you put this high-powered, explosively curious brain into a sterile, low-range glass box, it gets incredibly bored. To a captive octopus, every pipe, Every overflow valve, every microscopic seam around a lid is an irresistible puzzle. In fact, to finally stop the jailbreaks, aquariums had to stop relying on heavy metal locks. Instead, they lined the tops of tanks with cheap astroturf. The irregular, prickly bristles prevent the octopus's suckers from forming a vacuum seal, completely neutralizing their grip. A plastic lawn defeated an evolutionary masterpiece. The octopus is an entirely separate experiment in the evolution of the mind. To them, a glass vault isn't a prison, it's just a puzzle with seams. And if there's even one opening big enough for its beak, the puzzle already has an answer.